One of the most challenging of our colligative property calculations is when we require students to determine the molar mass of an unknown compound. So I want you to, of course, do a couple things here, but before you do it, I want to just think about molar mass for a minute, okay? Molar mass, we know, is the mass of a mole of substance. It has so many grams per mole. Now typically when we want to know the molar mass, we know its identity and we go to the periodic table and we calculate the molar mass knowing its identity. But if you look at this problem, we see that it is an unknown, okay? And we're trying to determine its molar mass. In an unknown, one of the things that's easy to know is how many grams you weighed out to do the experiment. So you see that we have a carbohydrate here. It tells us it's a non-electrolyte. Okay, what does that tell us? What does that tell us about the I? Well, if it's a non-electrolyte, its I is 1, so that's a piece of information they're giving us there. But we're trying to determine its molar mass, and they went through and they weighed out a certain amount of that. So we know this number up here right off the bat. They told me how many grams. Our whole goal then in all of this information is to figure out the moles. Now, you're going to do one of two things here. After you write down the problem, you can just pause me and you can work it and see how you did and advance forward to see if you got the same answer. I am going to talk my way through this problem, but it's always better not to watch me do it, but to try to do it. Okay? Now, what are you doing? You're using the colligative property information, which in this case is what is it? Sorry, osmotic pressure. They're giving you osmotic pressure. So we've got pi equals, there's our equation, okay? Where in here does moles show up? Well, it's inside of that, okay? So you're going to use this osmotic pressure and somehow be able to extract out just the moles to plug into the bottom half of our molar mass. If you will be extremely careful with your units, you will be able to figure out how to do that. Don't be lazy with those units. Keep track of them, okay? So, take your choice. But I really would love to see you give it a try for as long as you're willing to push, okay? And at some point when you lose heart, okay, you can rejoin me and you can watch me through it, or you worked through it, you can scroll through to the end and say, did I get the same answer as Dr. Woodrum got? Okay? All right, so I will get started. I know that I need moles, and moles is buried inside of molarity there. So I am going to go ahead and use this equation and assume that I've been given everything else I need in order to get molarity. Okay? So pi divided by T, R, and I gives me molarity. Okay? Why did I want molarity? Because molarity is moles per liter. It has the moles inside of it. So I see that they gave me the osmotic pressure of 4.61 atmospheres. I see the temperature is 20 degrees Celsius, and I am reminded that whenever I use this equation, I need it in Kelvin. So 20 degrees plus 273 is 293 Kelvin. So I have my T. My R I use is the 0.08206. Now here's where students get lazy very often and they don't write the units for that because it is a little bit of a pain. But go ahead and write it. It doesn't take that long. Liter atmospheres per mole Kelvin. Okay, and that is that. And then my I, we've established that it's a non-electrolyte, so my I is 1. All right, what cancels? Atmospheres cancels. All right, Kelvin is on the top of the bottom, and this is on the bottom of the bottom, okay? And when you divide by a fraction, it flips it over. So when we do all of this calculation, we will have moles per liter, and I have a value of 0.192, 0.192 moles per liter. Moles of what? My unknown. Liters of what? solution. Okay, so it's always good not just to have a number or a number and a unit, but a number, a unit, and a substance so that we know what we're dealing with. Now, what does the rookie do? They take this number and plug it in right there. We don't want to do that. By the way, let's just go ahead and let us put the grams in top, because eventually we need to have the moles in the bottom. The grams value is 6.85. All right, grams. Now don't put that in there because that would be grams per mole liter. That's not molar mass. Molar mass is just grams per mole. So somehow I got to get rid of the liters of solution. Well, how am I going to do that? Well, all I have to do that, moles of unknown divided by liters of solution, that's the molarity that I just determined. I look back at the problem and I see that it says I have 100 grams of water. If I could multiply by liters of solution, I would know just the moles of the unknown. Well, it's liters of solution. All right, so let's see. This is, oh, they give me a density. Good, 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 good. All right, so we've got to know about my solution. I have 100 grams of water and 6.85 grams of the carbohydrate. So that would be 106.85, and truly I only know it to 1 decimal place because I only know the grams of water to 1 decimal place, but I'll go ahead and carry them all. This is how many grams of solution I have. All right, I want to know it in volume. All right, that's liters. So I'm going to use the density. And the density is 1.024 grams per milliliter. And that's of solution, right? But I don't want to know that either. I need to know it in liters because I need to cancel here. So liters of solution, oops, milliliters is what I'm going to cancel. And I'm going to go to liters of solution. Milli means 10 to the minus 3. Now, I did not calculate that before, so let me go ahead and put this into my calculator here. 1.024, and I have a liters of solution of 0.104 liters. Now you can see that as 100 grams, if it was pure water, that'd be 100 milliliters or 0.1 liters. We have a little bit of added stuff to that, don't we? The solution is actually this value here. So now I know that I have 0.104 liters of solution, and I can take the 0.192 and multiply it by that value, and I have 0.0200. The liters are canceling, and moles is my answer. Now, whenever I get to an equal, I like to stop and think, why did I do all that? What was the reason I was doing that? And I have to go back up and start thinking about, what am I calculating? So I read the problem. It says we are calculating the molar mass. That reminds me of my equation up here. It reminds me I needed grams per mole. And I can say, oh yeah, that's why I calculated my moles. I'm going to put that right here, 0.0020 moles. So I'll take the 6.85 and divide it by that number, and I have 342 as the molar mass of this unknown electrolyte. Okay? Let me just say one last thing about this before we let it go. This, calculating the molar mass of an unknown using colligative properties, is typically either done with freezing point depression because it's a very sensitive technique, or osmotic pressure. But there's not a memorized process. It's all about your units. Molar mass is grams per mole. Okay? I need those two things. Grams will always be given to me. I will use the colligative property to whittle down to eventually find just the moles of that unknown. Okay? Putting them together will give me a molar mass.